Can you hear me? Good morning.
Good morning. Yes, sir.
I'm going to start the class for today, and we're going to have a review session on next week, Tuesday, and we will be taking test 2 on next week's Thursday. So I will be recording for other people as well. I'm going to go to direct. Do you have any questions?
No, sir.
I'm going to go to chapter 4 and go over the material, rest of the material in chapter 4. All right. I'm going to share my chapter 4 slides. Can you see my chapter 4 slides? Chemical reactions and energy calculations.
Yes, sir.
All right. We talked about chemical reactions. We defined reactants and products, type of reactions, and also talked about balancing chemical equations. We also talked about how ions participate in aqueous solutions to form precipitate acid-base reactions, gas formation reaction, and also oxidation reduction reactions. Today, the topic is stoichiometry. We're going to show you how you use formula weights, molecular weights to do calculation using chemical equations. So we're going to talk about stoichiometry. One of the main ideas in stoichiometry is mole concept. Mole concept is used to calculate grams of products that you can obtain from a particular chemical reaction. Therefore, it's a very important concept. I'm going to go over it in detail. So this whole stoichiometry idea is the mass calculation in chemical reactions. We're also going to look into how heat is produced in chemical reactions, endothermic, exothermic reactions, and how heat of reaction is calculated in using a chemical equation. We can use molar mass to convert grams to moles, from moles to grams. Either we can start with the molar mass is the formula weight. We also call that molar mass. Formula weight gives directly how many grams are in a 1 mole of substance. That's the formula weight unit. For example, formula weight of water is 18. You add up 2 hydrogens and 1 oxygen and get mass of 2 hydrogens and oxygen. You get 18. Hydrogen is molar mass is, or formula atomic mass is 1. Atomic mass of oxygen is 16. 2 plus 16 is 18. Normally, atomic masses are given in grams per mole. This is why formula mass is also called molar mass. It's given in grams per mole. It tells you how many moles are in a 1 gram of certain gram of formula weight. So converting grams to mole, you use the molar mass or the formula weight as a conversion factor. For example, 36 grams of water. How many moles of water are there? So you use the formula mass or molar mass to convert. You get 2 moles of water. How do you get 2 moles of water from 36 grams? 36 divided by formula weight or molar mass. So 36 divided by 18 is 2. This is shown in detail here. Moles of water in 36 grams of water. So here you are dividing moles by formula weight. It's 1 over formula weight. So you get the 2 moles of water. If you need to calculate moles of water to convert moles of water to grams of water, so you multiply by formula weight. If you divide here, you multiply here. So therefore, grams to moles conversion is pretty easy once you know the formula weight or the molar mass. Let's describe formula weight in little more detail. Formula weight is the sum of the atomic weight in mass unit, atomic mass unit. Atomic masses have atomic mass unit. Atomic mass units are same as grams or mole units. If you look at sodium chloride, how do you get formula weight? Sodium is 23. Chlorine is 35.5. There's one sodium, one chlorine. Therefore, these add up. Sodium chloride add up to 58.5. It's pretty simple. You look in the periodic table, the masses of the atoms forming the formula, and add them up and get the formula weight. Ionic compounds, nickel chloride. This is nickel 2 chloride hydrate. Don't worry about this water molecule. That's when the nickel chloride crystallizes. It includes water molecules. That's how the nickel chloride is found as hydrate, hexahydrate. So you have to calculate the number of atoms of nickel. 1 nickel atom, 2 chlorine atoms, 12 hydrogen atoms, and 6 oxygen atoms. You multiply by the subscript of each element, and you get formula weight for nickel hydrate, hexahydrate is 237.7. These are ionic compounds which consist of ions. Molecular compounds are different from ionic compounds. We already talked about it. Molecular compounds are covalent compounds where electrons are shared between atoms. Water has 2 hydrogen, 1 oxygen. You add them up. We already shown you how you get the formula mass of water. Aspirin, the pills you take for headaches, has 9 carbon atoms, 8 hydrogen atoms, 4 oxygen atoms. They add up to 180.0. Notice the units of formula weight. It's grams per mole, which means if you take 18 grams of water, that's a 1 mole. Therefore, formula weight in grams per mole also tells you the mass of the 1 mole of that particular material. Mass of 1 mole of water is 18 grams. We're going to talk about what mole means in next few slides. Formula weight could be, as we described in the previous slide, could be for ionic compounds or covalent compounds or molecular compounds. Formula weight is used for both ionic and molecular compound, covalent compound. Molecular weight is used only for covalent compound. That's how we use weight, molecular weight, formula weight. In this text, formula weight is used for both ionic and covalent compound. Also, there's another name for formula weight. That's called molar mass, MM. Since formula weight units are in grams per mole, it gives directly the mass of 1 mole of a substance. So therefore, molar mass is also used to indicate formula weight is giving mass of 1 mole of material. How do you calculate molecular weight of sucrose? Sucrose is sugar, C12H12 I look up in the periodic table. The average atomic masses for carbon is 12.0. Atomic masses in periodic table are given in AMU, or AMU is same as grams per mole. So we're not going to use grams AMUs in stoichiometry. We use grams per mole. Hydrogen is 1.0. Oxygen is 16. Now you multiply each element by its substrate to get the total mass of 342.3 grams per mole for sucrose. Here I multiply each element mass, atomic mass, 22, 11 oxygen, 22 hydrogen. So when you calculated formula mass, molecular weight, molar mass, it turned out to be 342. Therefore, correct answer for this question is C. Barium phosphate. This is formula weight or molar mass. You look up in the periodic table. You get the molar masses of barium, phosphorus, oxygen. There's no 1 here, 137. Then you multiply barium mass 3 times, 2 times phosphorus mass, 8 times oxygen mass. You get 601.9. Therefore, correct answer is D. Which of the following compound has largest formula weight? You look up in these compounds. You look for the potassium there are chlorines, molar mass or atomic mass of potassium, sodium, magnesium, fluoride, and boron. I listed from the periodic table these masses. Then you add them up to get the formula weight of each compound. They are asked in the largest formula. Since potassium is the heaviest among all of them, and then the chloride is the next heaviest. Potassium chloride is the heaviest of all, largest formula mass. Therefore, answer is A. I talked to you about mole concept. Formula weight gives how many grams of material of that particular compound 1 mole of molar mass of for that particular compound. Mole is a number, amount, contains many atoms. Strictly speaking, mole is defined as 1 mole of substance in carbon-12, 12 grams of carbon-12 isotope. Carbon-12 isotopes is this. Mass of a carbon-12 isotope is 12 AMU or 12 grams per mole. That is the standard, like a pound in British system. Therefore, for mole concept, the standard is carbon-12, 12 grams of carbon-12 has 12 atomic mass in it, or 12 grams per mole. As I said before, AMU is not used in stoichiometry. 1 AMU is same as 1 gram per mole. A mole is certain number, regardless of the material. 1 mole of any material has same number of formula units. In iron, there are same number of iron atoms as in methane molecules. Same number of methane molecules. Same number of sodium ions. Therefore, it's a 1 mole of anything has the same number. This number is called Avogadro's number. Avogadro's number is experimentally determined. You can calculate it with the high accuracy, with 8 decimal places. It has been calculated. Look at the exponent. There's a large exponent, 10 to the 23. This is rounded off to 6.022, 10 to the 23 in most of the stoichiometric calculations. How we convert grams to moles? We already talked about it. Grams divided by molar mass or formula weight, you get the number of moles. To calculate moles of sodium ions in 5.6 grams of sodium sulfate, that's the formula. First you need to find the moles in 5.63 grams of sodium sulfate. To get that, you have to get the formula weight. We already talked about how to get the formula mass or molar mass formula weight. You add up all the masses of sodium ions, sulfur, and oxygen. Formula weight of sodium sulfate is 140.1. Once you get the formula weight, 5.63 divided by 142 gives the number of moles of sodium sulfate. So this is 5.63 divided by formula weight. 142 is now in the denominator. In sodium sulfate, there are 0.0396 moles of sodium sulfate. That's how you calculate. But the question is how many, this is the question. How many sodium ions in there? If you look at the formula of sodium sulfate, there are 2 sodium ions. 1 mole of sodium sulfate contains 2 moles and 1 mole of sulfate. Therefore, 2 times 0.0396 is the number of sodium ions. That gives 0.0792 moles of sodium sulfate. That is the answer to this question. That's how you calculate number of moles from grams and the formula weight of a substance. Let's answer a few questions. Helium and beryllium, there are 2 elements. Atomic masses are given. Helium has 4.0 and beryllium has 9.01. Which of the following is true? 1 mole of beryllium contains more atoms than helium. That's not true. 1 mole has same number. A mole of helium is heavier than mole of barium. If you look at that, these are moles. Helium is not heavier, lighter. Therefore, that's not true. A mole of barium contains the same number of atoms as a mole of helium. That's correct answer. There's no more than correct response. Therefore, C is the correct answer. That's how you answer questions about mole concept. Let's look at 1 mole of sulfuric acid. It gives out choices. You have to check out whether these are true or false. 2 moles of hydrogen atom. That's correct. There are 2 hydrogen atoms. Therefore, 2 moles in 1 molecule of sulfuric acid. 1 mole of substance. There's 1 here. That's true. This is true. This is true. Now, 7 atoms of, if you add them up, 2 hydrogen, 1 sulfur, 4 oxygen, it adds up to 7. So therefore, answer is more than 1 correct response. Let's look at mole concept again. A mole of a chemical substance represents mass of a substance that will combine with 12 grams. We talk about carbon 12, but that's nothing to do with carbon 12. The mass of a substance that will combine with oxygen. That's not true. 6.02 10 particles of substance. That's correct. That's the Avogadro number, rounded off to second decimal place. Now 6.02 10 to the negative 23. That's not right. Avogadro number is a large number. It's 6.02 10 to the 23. Therefore, correct answer to this question is C. We're going to look into more questions using mass relation, mole grams conversions in stoichiometry. We talked about aspirin. It has formula weight or molar mass of 180. We calculated in the table. How many molecules of aspirin are present in? This is grams to molecules. To get the grams, molecules from grams, you have to start with grams, converted to moles, converted to molecules. Moles multiplied by Avogadro number gives molecules. First, we have to find the moles of aspirin. Okay. So moles of aspirin are found by grams of aspirin divided by formula weight of aspirin, which is 180. We get the moles of aspirin. How do you get the molecules? Each mole has Avogadro number of particles or molecules in this case. Therefore, we have to multiply moles with Avogadro number. So this is the Avogadro number, moles multiplied with there's how many molecules of aspirin. So once you have moles of anything, to get number of ions, atoms, molecules, you multiply with Avogadro number. Moles multiplied with Avogadro number gives the number of particles, which could be ions, molecules, atoms. Let's check this question. Avogadro number of argon. Avogadro number is 6.02, 10 to the 22. Have a mass of. What is the mass of argon? 1 mole of argon is the question. Normally, to get the 1 mole of mass of 1 mole of a substance, you look up in the periodic table, get the formula weight of argon, which is 40. Therefore, 1 mole of this says 1 mole per means 1 mole. It has to be 40. Answer is D. 0.789 moles of particular substance weighs 142 grams. What is the molar mass? Molar mass is grams per mole. Therefore, you have the moles here, grams here. Therefore, 142 divided by right here gives formula mass. Formula mass could be grams per mole or AMU. We don't hardly use AMU, but this choice only leaves out with this choice only. There's no grams per mole given. Therefore, formula mass of a molar mass of a substance is 180 AMU. Answer is D. In the next problem, 0.117 moles of particular substance have 21.9 grams. Again, grams divided by moles. So this is 21 grams. You pick up from the 21 here. And 117 is the number of moles you picked up from here. It's 187. Again, this is a choice only given in AMU. Therefore, correct answer is B. A person drinks that many grams of water per day. How many moles is this? How many moles? So to get the moles, grams divided by formula mass. Formula mass of water is 18. Therefore, this number divided by 18 is 83.3. This is the answer. C is the answer. A serving of particular fruit dessert contains 20 grams of sugar. Sugar is sucrose, C12H22O11. We said formula mass is 342. We calculated it before. How many molecules of sugar are present in the serving? So first you have to convert 20 grams to moles. 20 divided by formula, that's the moles of sugar. And how do you get molecules from moles? Multiplied by Avogadro number. Therefore, you get the correct answer. All right. Now we got the introduction to formula mass and how to convert grams to moles. Now we're going to look into little more details about using chemical reactions to calculate amount of products that can be obtained during a particular chemical reaction. Stoichiometry is the study of mass relation in chemical reactions. If you have a reaction, A is going to B. The stoichiometric coefficients are 1 here. How do you do a stoichiometric calculation? First, you start with A, grams of A. Convert that to moles of A. How do you do that? Grams of A divided by formula mass of A. Then use mole conversion factor. That's 1 to 1 here. Stoichiometric coefficient factor, conversion factor. Get the number of moles of B. Then normally we look into not moles, grams of product. Moles of B multiplied by formula mass of B, get the grams of B. That's the complete stoichiometric calculation. You will be given a chemical equation and told how many grams of the formula in the reactant site is used in the chemical reaction. Then how much particular product is formed. So you have to give that in grams. You start with grams, convert it to moles of the formula, then through the chemical equation, use stoichiometric coefficient to convert moles of certain amount of compound to another compound. Therefore, it is typical chemical stoichiometric calculation. We talked about grams to moles. Grams divided by formula mass, molar mass, gives the number of moles. For example, the question is, how many grams of nitrogen are required to produce 7.50 grams of ammonia? So you start with ammonia, convert to ammonia to moles, then through the stoichiometric relationship 1 to 2, convert ammonia to moles of nitrogen, then moles of nitrogen to grams of nitrogen. First find how many moles. 0.75, 7.5 divided by formula mass. Formula mass of ammonia is 17. You add nitrogen and hydrogen. So you get the number of moles of ammonia. So this calculation could be done with the factor label method in one calculation. Then moles of ammonia need to be converted to moles of nitrogen. So let's look at the total calculation. That's the beginning, 7.5 ammonia. Ammonia is converted to moles of ammonia here. Then the moles of ammonia is converted to moles of nitrogen here. Then grams of nitrogen. This is the stoichiometric coefficient ratio. Therefore, answer to that question in the previous is 6.18 grams of nitrogen. If you start with 7.5 ammonia, you end up with. That is a typical stoichiometric calculation. There are more practice problems. There is a reaction between decomposition reaction of aluminum oxide. Aluminum is produced from electrolysis of aluminum oxide. Oxygen is and aluminum is produced. This reaction is not balanced. Therefore, we need to balance. To balance this equation, you put a 2 in front of here, 4 in front of here, and 3 in front of. Now the reaction is balanced. So we have to use in the next slide, I'm going to show the calculation, how you convert 1 mole of aluminum to aluminum oxide. The formula mass of aluminum is 27 from the periodic table. Therefore, there's 1 mole of aluminum, 1 mole. So 1 mole get half of that to the aluminum oxide. Then we do the calculation. There's a second equation. This equation is balanced. I checked out. Calculate the number of nitrogen atoms, hydrogen atoms, carbon atom, it is balanced. So there you don't have to balance it. So using these two equations, let's look at the conversion of 27 grams of 1 mole of aluminum. You start with 1 mole of 27 grams. Convert that to moles. So this cancel out. Then the moles converted to aluminum moles. That's 4:2. Then after that, aluminum moles, aluminum oxide, formula mass is 102. This one is 102. Grams multiplied by formula. You get the grams of aluminum oxide, 102. That's the answer to the question. How many grams of each? That's the second reaction. We chose balance. That's the urea with water produce ammonia and carbon dioxide. The question is, how many of each are produced from that many moles of urea? So this is easy question. You don't have to calculate moles. You start with moles of urea. Convert that to moles of ammonia to the conversion factor, 1:2. There's a 1 here. Then multiplied by formula mass of ammonia, 0.083 moles of urea will produce 28 grams of ammonia. That's how you get it. Let's look at a few more problems. The following equation. The correct numerical value in moles, carbon dioxide. When 9 moles of water are produced. So you have to get the conversion factor between carbon dioxide and water. Carbon dioxide is this. Therefore, it's 4:6. You write down that 4:6 here. Then simplify it. 6 divided by 6 is 1. 4 divided by 6 is simple ratio is 2.3. Therefore, 9 moles of water. You multiply 9 right here. And also you have to multiply 2 divided by 3 by 9. So you get 6 moles. Therefore, answer to that question is correct numerical value is A. We got the answer here. A similar calculation. Correct numerical value of when 2 molecules of ethane that react with oxygen. So this is the conversion factor, 2:7. I wrote down 2:7 right here. Then if you look at this is same as 2 moles of, therefore it produced 7. You don't have to do anything. 7 molecules of moles of oxygen is produced. Therefore, answer is B, 7. It happened to be easier because the ratio falls into the same as given in the question. Which one of the following conversion factors is not consistent with the equation? Conversion factors are important in converting certain chemical to moles of other chemical, like we used in previous problems. You look at oxygen and water, 5 to 6, that's correct. Between nitrogen and NO and it's 4 to 4, that's correct. Now you look at between ammonia and water. Ammonia and water is 4 to 6. This one correct, but this one is not correct. That's 6. Therefore, this is the incorrect. This one is also correct. If you look at NO and O2, NO is 4, O2 is 5. Therefore, not consistent conversion factor is C. Octane is one of the principal components of gasoline. Gasoline has octane ratio. How many moles of carbon dioxide are produced during the combustion of 3 moles of octane? This equation is not balanced. We already know how to balance. Let me balance it. That's the balanced equation. Question is, how many carbon dioxide produce octane? Therefore, you have to find the conversion factor between carbon dioxide. That's 1. That's 2 to 16 is 2 to 16 is simple ratio is 1 to 6. Therefore, 1 times 3 is 3 here. Therefore, 24 moles of carbon dioxide is produced. The answer to the question is C. There's another calculation. Correct number of carbon dioxide moles produced when 9 moles of water are produced. So you have to find between carbon dioxide and water. That's 4 to 1. 4 to 6. That's here. That's here. I wrote it down. Then I simplify. 1 mole of water is equal to 2/3 of carbon dioxide. This is 9 moles. Therefore, you calculate for 9 moles of water. That gets 6 moles of carbon dioxide from 9 moles of water. The answer is 6. 6 is the choice A. That's how you do the calculation. Ethanol is produced industrially by acid catalyzed reaction of ethylene and water. We drink a lot of alcohol. That's one of the ways from petroleum industry. Ethylene is converted to water, get the alcohol. If water is present in excess, so this is excess. Therefore, amount of ethanol produced is decided by amount what you have, number of moles of ethylene. So if you use 7.2 moles of ethylene, how much ethanol is produced? That's the question. So this is stoichiometric calculation. Ethylene to alcohol, ethanol. First, you have to calculate moles of ethylene. You start with 7.24 moles of ethylene. It's 1:1. This is 1:1. Therefore, you get 7. It's not the answer, grams. You have to multiply by molar mass of ethanol. Molar mass of ethanol is 46. Moles multiplied by molar mass. You get 334. Therefore, grams of ethanol. That's the correct answer. You have to carefully look at what you're converting and how you get the conversion factors from one chemical to another. How do you convert ethylene to ethanol? Now, there's one more concept involved in stoichiometry. It's called limiting reagent. Limiting reagent is the reactant used up first in a chemical reaction. If a chemical is used up first, it stops the chemical reaction. Therefore, doing stoichiometric calculation, finding the limiting reactant is important. If you consider nitrogen and oxygen reaction to produce NO, you start with 5 moles of nitrogen, 1 mole of, at the beginning there's no products. After the reaction is complete, oxygen is used up. That's the limiting reaction. Since it's 1:1, if you have 1 mole of oxygen, there are going to be excess of 4 moles because 1:1 reaction. You can see oxygen limits the number of NO molecules produced is 2. Therefore, oxygen is the limiting reactant. In this experiment, 1 mole of oxygen will react with 1 mole of nitrogen to produce 4 moles of 1 mole of nitrogen, leaving out 4 moles. There's 4 moles excess. Oxygen used up first. Therefore, it is the limiting reactant or reagent. 4 moles of right here, 4 moles of nitrogen remain unreacted. That's the excess reagent. So when you're doing a limiting reagent calculation, you need to know how to find out limiting reactant and the excess reagent. When you do reaction in water is the excess, it's not the limiting. So most abundant reactant is going to be excess. Therefore, other reactant going to be limiting. Let's look at some more detail of limiting reagent. For this reaction, stoichiometric coefficient of carbon is 1, all ones. Let's create a table for the data. If you start with 12 grams of carbon, 64 grams of oxygen. So how do you calculate? Carbon is formula mass is 12, oxygen is 16, oxygen is 32, 2 16ths. Therefore, 2 moles of oxygen, 1 mole of. Therefore, limiting going to be carbon is used up after reaction. Still, only 1 mole is used. Therefore, 32 grams of oxygen remain. That's the excess. 1 mole of carbon produce 1 mole of carbon dioxide. Therefore, you get 44 grams of carbon. So which is the limiting reagent? Clearly it's carbon. You can look at some diagrams and try to get more clear idea about how you get the limiting reactant. There's a diagram in this problem. The A's are large circles. B's are small circles right here. So it's a 1-to-1 reaction. Therefore, you have to have equal number of A's and B's. You count the number of A's, large gray circles. There are 5 of them. Dark circles. There are 8 of them. This is 1-to-1. Excess reagent is, limiting reagent is this. This is excess. Therefore, limiting reagent is A in this diagram. You can compare the stoichiometric ratio and the number of particles and tell the what is limiting. There's another reaction, similar reaction, but now 1-to-2. Large white circles, how many of them there? 8. Small gray circles, this one. There are 6 of them. Now it requires 1-to-2. If you look at 1-to-2. Therefore, which is in excess? 8 requires 16. You have only 6. Therefore, this is limiting. Therefore, B is the correct answer. Now let's look at this about limiting reactant. You mix up nitrogen and oxygen. This is the stoichiometric coefficient, 1, 2, 2, 2, 2. Initial quantity, 5 molecules, 12 molecules. There's none of the product formed initially. So in this case, 5 molecules require 10. Therefore, 10 out of 12 is used. Therefore, 2 molecules of oxygen remain excess. So this, how many 5 molecules are used? When you use 5 molecules, there will be 10 molecules produced because 1 times 2. So how many molecules are produced? NO2, 10. So answering this question, limiting reagent is, this is the excess after the reaction. Oxygen is excess. It's not the limiting. So correct answer is, this is the question. That's a 10. That's it. In the industrial synthesis of acetic acid from methanol, methanol is not a drinking alcohol. That's a different alcohol. Acetic acid is produced. So how many moles of carbon dioxide are required to 16.6 moles of acetic acid? So I calculated similar to previous problems. You go over this calculation. Answer is B. 16.6 moles of acetic carbon dioxide, carbon monoxide are required. Now the last topic on the topic I'm going to go today is percent yield and how to tell the efficiency of a chemical reaction. Actual yield is not the stoichiometric yield that we calculate using chemical equation. Actual yield is what is obtained in a real experiment in a chemical laboratory. Theoretical yield is calculated. What we have been doing is calculating theoretical yield using balance equation. Percent yield is showing how efficient your reaction is, how efficient is your reaction converting reactant to product. Percent yield is calculated actual yield divided by theoretical yield. Actual yield is the one right here. Theoretical yield is stoichiometric calculation multiplied by 100. Suppose we react 32 grams of methanol in excess carbon monoxide, 58 grams of acetic acid is produced. Complete the table. This is theoretical. You calculate from 32. Formula mass of methanol is 32. Formula mass of acetic acid is 60. So 32 divided by 32, you get 1 mole. Now this is not used, excess. Now you convert stoichiometric calculation is starting in methanol to acetic acid. 1 to 1. Therefore 60 grams of is produced. Therefore theoretical yield is 60. Actual yield is what is obtained in the laboratory. That need to be given to you. Normally theoretical is greater than actual. This is 60 is greater than 55. Therefore 55 divided by 60 multiplied by 100 gives the percent yield of the reaction. Let's do a few theoretical yield calculations. Theoretical yield calculated using the stoichiometry is 34. Actual yield is lower, 31. So you plug in the actual yield here as 31 point divided by 34.7, 89.9% yield. That's pretty simple once you have the grams of actual yield and the theoretical yield. Answer is C. Suppose the theoretical yield is 10.5. Percent yield is, now you are asked for actual yield. You rearrange the equation. This equation is rearranged. Now you are dividing by 100. Percent yield multiplied by theoretical yield divided by 100. That's the percent yield. That's the theoretical yield. You get actual yield of 7.93. That's how you calculate using this equation. Percent yield is equal to actual yield divided by theoretical yield. Answer is B. Now this is a reaction between decomposition reaction of ethanol to diethyl ether and water. You start with 26 grams of ethanol. Yielded, that's the actual. What is the percent yield of the reaction? This is the actual. You have to calculate the theoretical. So let's calculate the theoretical. You start with 46 grams of ethanol. Converted to 1 mole of, this is 2 to 1. Therefore, 46 grams has 1 mole. 1 mole is the half mole of, that's half of ethanol. Therefore, number of moles is this multiplied by 74 is the formula weight of diethyl ether. This 74 is formula weight. Therefore, grams of theoretical yield is 37. Actual yield is right here. Therefore, 34 divided by 37 multiplied 93.3. Correct answer is C. I'm going to stop the class for today. You guys are all right? Are you guys there? Are you guys there?
Yeah.
I'm going to have the meeting at 1 o'clock, same time period, same time, 1 p.m. starting next Tuesday. So we're going to review up to whatever I talked about in chapter 4 is going to be on the test. So we're going to review up to last 2 topics we didn't talk about. So stoichiometry is the last topic on chapter 4. All right. You guys have a great weekend. All right.
You too.
Take care.
Have a good one.
Yeah.